section 1.2 in our BJU pre-calculus book, and this section is about trigonometric ratios. So really what we're trying to do today is look at the Pythagorean theorem, and we're going to define 6 trigonometric ratios. So Pythagorean theorem, as you might have remembered from geometry, is a squared plus b squared equals c squared. In a right triangle, and only in right triangles, the sum of the squares of the lengths of the legs, so if you're looking at a right triangle, this is a length here, and this is a length here, and if you add the squares of those lengths together, you would get the square of the hypotenuse. Remember, the hypotenuse is always the side across from the right angle. So a squared plus b squared equals c squared. So also remember that the a from a squared, that little a, is across from angle A, which is a capital A. So this is little a here, this is little b here, and of course this is side C, which is always your right angle. All right, so when we say trigonometric ratios, ratio, remember, is a fraction. It's something over something, something to something. So our first trigonometric ratio is called a sine. A sine is just the ratio of the leg opposite of that angle over the hypotenuse. So remember, a ratio is just a fraction. And when we say sine, we're saying give the ratio of the leg opposite of the angle you're looking at over the hypotenuse. Cosine is a different ratio. Cosine is going to be the adjacent leg over the hypotenuse. And then we have tangent, which is the leg opposite of the angle over the leg adjacent to the angle. So a great way to remember our trig functions is the phrase SOHCAHTOA. So you might think of, I don't know, like a SOHCAHTOA, kind of like a song. So S-O-H, S is for sine, and the O and the H is the ratio. So sine is opposite over hypotenuse. The K is for cosine. The A is the adjacent, and the H is the hypotenuse, because cosine is adjacent over hypotenuse. TOA stands for the tangent, which that ratio is opposite over adjacent. So the O is opposite and the A is adjacent. So if this is angle A right here, then that's opposite of A, and this is adjacent to A. And of course, that's our hypotenuse. So if we want to know what sine of A is, we're looking for the opposite over the hypotenuse. If we're looking for the cosine of A, we're going to put the adjacent over the hypotenuse. And if we're looking for the tangent of A, we're going to put opposite over adjacent. Now let's talk about reciprocal ratios. So we learned our 3 basic trig ratios. We had sine, cosine, and tangent. But remember, there are 6 trig ratios that we have to learn. And the other 3 actually come from the reciprocal of our original 3. So the first reciprocal ratio is cosecant, which is going to be the reciprocal of sine. So cosecant, we shorten that because that's a really long word, and we put CSC, and that's cosecant. So if we want cosecant of an angle, that's equal to 1 over the sine of the angle, or the reciprocal of the sine. Secant is the reciprocal of cosine, and secant we shorten to SEC, secant. And then we have cotangent, which is the reciprocal of tangent, and we shorten that to COT. So here again is my right triangle. Let's see, that's angle A right there. If I want cosecant, remember cosecant is the reciprocal of sine. The way I remember, like, which one goes with which, like cosecant and secant, which one goes with sine, which one goes with cosine. I think of the letters like switching, like cosecant starts with the C, which means it's a reciprocal of sine, and secant starts with an S, so it's a reciprocal of cosine. So they kind of swap the first letters, right? So cosecant is a reciprocal of sine, and sine is opposite over hypotenuse, which means cosecant is a reciprocal, so it's hypotenuse over opposite. Then we have secant, which is the reciprocal of cosine, and since cosine is adjacent over hypotenuse, the secant would be hypotenuse over adjacent. Then we have cotangent, which is the reciprocal of tangent, and since tangent is opposite over adjacent, that means cotangent is adjacent over opposite. Let's look at example 1. So in example 1, we are missing a side, right? We're actually missing side G, because side G is across from angle G, and side G is not given to us. So we have to use Pythagorean Theorem. So we know that side G squared plus side E squared is equal to side F squared, because F is our hypotenuse. So if we'll do the math, G squared plus 6 squared equals 8 squared. And then G squared plus 36 equals 64. We're going to subtract 36 from both sides. So G squared equals 28. Then we square root both sides. So the square root of 28 is the same as saying the square root of 4 times 7. And the square root of 4 is 2. So that means G is 2 square roots of 7. Now we can get our trig ratios. Let's start with sine. So remember, sine is opposite over hypotenuse. And since we're getting sine of G, we need the opposite of angle G. And opposite of angle G is down here. And we just figured this to be 2 square roots of 7. So we have 2 square roots of 7 over 8, which reduces, because 2 goes into 8 4 times, to the square root of 7 over 4. Now let's look at cosine. Cosine is adjacent over hypotenuse. So adjacent to angle G is 6 over hypotenuse 8, which reduces to 3 over 4. Now we've got tangent. Tangent is opposite over adjacent. So opposite of G is 2 square roots of 7 over adjacent 6. And 2 goes into 6 3 times. So we get our answer, the square root of 7 over 3 for tangent. Now let's look for cosecant. Remember, cosecant is the reciprocal of sine. So if sine is the square root of 7 over 4, we can just flip that to find our cosecant, which means cosecant is 4 over the square root of 7. Now we want to rationalize that by multiplying the numerator and the denominator by the square root of 7, which gives us 4 square roots of 7 over 7. Next, let's look at secant. Secant is the reciprocal of cosine, and since cosine was 3 over 4, secant will be 4 over 3. Cotangent is the reciprocal of tangent, and since tangent was the square root of 7 over 3, cotangent will be 3 over the square root of 7. Again, we have to rationalize, so we will multiply both top and bottom by the square root of 7. 3 times the square root of 7 is 3 square roots of 7, and then the square root of 7 times the square root of 7 is 7, giving us our answer for cotangent G being 3 square roots of 7 over 7. Let's look at this practice question. We want to know what sine of angle E is. In order to get sine of angle E, we have to have the opposite over the hypotenuse. So opposite of angle E would be 9, and the hypotenuse is 11, which means our answer is option 1. 9 over 11. So for this problem, we didn't even have to solve for side g because it was not needed. We only needed the opposite and the hypotenuse. All right, let's take a look at our coordinate plane because now we're going to talk a little bit more about our unit circle. So when you have an angle, our terminal ray is going to hit an ordered pair, an x and a y. And when it hits that ordered pair, that terminal angle, it's going to make a right triangle with the x-axis. And because of that, we can get trig ratios for that angle on the coordinate plane, with the x coordinate being the length of that leg and the y coordinate being the length of that leg. And because we know what the x and the y, the two legs are, we can then use the Pythagorean theorem to find our hypotenuse, which, if we're looking at our circle, is the radius. So, using our coordinate plane, we find that that angle, the opposite side of your angle, is the y value. And your hypotenuse is the r value, and the adjacent leg to the angle is going to be your x value. So again, opposite is the y coordinate, adjacent is the x coordinate, and of course hypotenuse is your r value or your radius. Your hypotenuse is r, or radius. So sine, which is opposite over hypotenuse, if you're looking at the coordinate plane, is going to be y over r. Cosine will be x over r. Tangent will be y over x. Cosecant will be r over y. Secant will be r over x. And cotangent will be x over y. So let's say we have the point 0, 1. If you look at the point 0, 1, you can see that's 90 degrees. And the point 0, 1, x is equal to 0 and y is equal to 1. And if you were to do x squared plus y squared equals r squared, you would find that r is equal to 1 as well. And because of that, now we can get our ratios. So cosine, remember, is x over r. So 0 over 1, which is 0. Sine is y over r. So 1 over 1, which is 1. And then we get tangent, which is y over x. So we've got 1 divided by 0. Well, you can't divide by 0, which means tangent of 90 degrees is undefined. Now let's get our reciprocals. Secant, which is the reciprocal of cosine, and if cosine was x over r, that means secant is r over x. So we get 1 divided by 0, which means secant is undefined. Now we look at cosecant, which is the reciprocal of sine, and if sine is y over r, then cosecant is r over y. So we get 1 over 1, which is still 1. Then we look at cotangent. Remember, cotangent of 90 was undefined. However, cotangent is the reciprocal of tangent, and tangent was y over x. So cotangent is x over y. So now we have 0 divided by 1, which is 0. So cotangent of 90 is 0. Let's go ahead and practice. Let's look at 180 degrees. Okay, what did you think the answer was? You should have gotten 0. So 180 degrees, if you're looking at your ordered pair, your x value is -1 and your y value is 0. because you are not going up or down, but you are going to the left, -1. And of course your r is going to be 1. So if you're looking for sine, sine is opposite over hypotenuse. But if you're looking at the coordinate plane, that's y over r. And remember, our y value was 0 and our r value was 1. So 0 divided by 1 is 0, which was option 2. Let's look at some special triangles. So we know that if we have a 45-degree angle, that means the other angle has to be 45. So if one side is 1, the other side has to be 1. And in our unit circle, we always like the length to be 1. And so we can figure out our radius here, because 1 squared plus 1 squared equals r squared, which means that the hypotenuse will be the square root of 2. So now we can find our trig ratios for a 45-degree angle. So sine of 45 is going to be 1 over the square root of 2, which of course we will rationalize by multiplying the top and the bottom by the square root of 2 over 2, square root of 2, which gives us the square root of 2 over 2. If we look at cosine, we still have 1 over the square root of 2, so we still get the answer, the square root of 2 over 2. Then tangent, which is opposite over adjacent, 1 over 1, which is 1. So now let's look at our reciprocals. Cosecant, which is the reciprocal of sine, so that's going to be the square root of 2 over 1, which is the square root of 2. Secant, which is the reciprocal of cosine, is going to be the same, the square root of 2. And then cotangent is still 1 over 1, which is still 1. So here's a recap of the 6 trig ratios for the special angle 45 degrees. You are going to have these memorized. But if you can remember that a 45 triangle, and you can remember 1, 1, square root of 2, you won't really have to memorize these. You'll be able to build them using trig ratios. Now let's look at another special triangle, 30-60, a 30-60 triangle. In this case, because if we were to add another 30-60 triangle here, we would have an equilateral triangle, right? Because this would be 60 and then this would be 60, which means that this is 1 and this is 2. This would also be 2 and this would also be 2, the whole length here. So because of that, now we can use Pythagorean Theorem. So we have 1 squared plus b squared, which is this length right here, equals 2 squared. So 1 plus b squared equals 4, and then b squared equals 3, and so that means b is equal to the square root of 3. So now we can get our trig ratios. So this is how I remember the 30-60 triangle. I remember it because on the 45-45, our hypotenuse was the square root of 2. And our 30-60, our hypotenuse is just 2. In your 30-60, 30 comes before 60, just like 1 comes first. So 1 is across from the 30. And then, of course, the square root of 3 goes across from the 60. And if you can memorize that triangle, you will never have to memorize your trig functions because you will always be able to build them with your special triangle. So let's look at these ratios. Tangent of 30. So you're looking at the 30, and tangent is opposite over adjacent. So 1 over the square root of 3. When we rationalize, we multiply the top and the bottom by the square root of 3, giving us the square root of 3 over 3. Now let's look at sine of 30, which is opposite over hypotenuse, so 1 over 2. And then cosine of 30 is the square root of 3 over 2. Now let's look at cotangent. Cotangent is the reciprocal of tangent. So if tangent was 1 over the square root of 3, that means that cotangent is the square root of 3 over 1, or just the square root of 3. Cosecant is the reciprocal of sine. And if sine was 1 over 2, that means cosecant is 2 over 1, or just 2. And then secant is the reciprocal of cosine. And if cosine was the square root of 3 over 2, that means secant is 2 square roots of 3 after we rationalize it. You would have started with 2 over the square root of 3, and you would have had to multiply top and bottom by the square root of 3, and that's how you got 2 square roots of 3 over 3. So here's a recap of our 30-degree trig ratios, which again you will need to have memorized. Now let's look at 60 degrees, right? So 60 for sine, the opposite is now the square root of 3. So the square root of 3 over 2. Cosine is going to become 1 over 2, and then tangent is the square root of 3 over 1, which is just the square root of 3. Now for our reciprocals. Cosecant, which is the reciprocal of sine, is going to become 2 over the square root of 3. So we have to rationalize that by multiplying by the square root of 3 on top and bottom, giving us 2 square roots of 3 over 3. And then secant is the reciprocal of cosine. And so since cosine was 1 over 2, secant is 2 over 1, or just 2. And then cotangent was the square root of 3 over, tangent was the square root of 3 over 1, which means cotangent is 1 over the square root of 3. We do have to rationalize again by multiplying top and bottom by the square root of 3, giving us the square root of 3 over 3. So here's a recap of our 60 degrees trig ratios that you will want to have memorized, or at least be able to build from your special triangle that you memorize. And that is the end of this lesson.